Hey guys, I hope you all are doing good. In this lecture, we will try to understand what are Hasse diagrams and what are diagrams, right? This is going to be an important topic to understand. And just like I said in the previous lecture, um, this is going to be like kind of a small series where we understand a lot of different small concepts, right? Stay tuned. Now, let's first start with understanding what is a digraph representation, and then we will try to understand what is a Hasse diagram, right? Before we start, just a quick thing. I hope you understand what is a partial order relation, right? So that's going to be important to understand the following lectures in this video, right? Okay. So a digraph is basically a visual representation of a binary relation on a set A, right? So each element is shown as a node. If A related to B, then we draw an arrow from A to B, and if A is related to itself, right? For example, if it's a reflexive kind of thing, then we draw a loop to represent it, right? So I hope you understand the very basics of it. This is kind of just like, so if I have some kind of a relation on a set, right? And a way to represent it is using a diagram. So it's very simple to understand. If some A is related to some other thing B, then we just draw an arrow from A to B, right? If it's related to itself, we draw a loop around it, right? And last thing is we represent each one as a node, right? So I'll try to give you a basic example. Let's take a look at this over here, right? So let's say I have the set 1, 2, 3, and 4, right? And I say they are related if A is less than equal to B, right? So if a value is less than equal to B, then we say, or I can say if A less than B, then A is related to B, right? So I hope you understand this. Now, before I draw the diagram, I need to first figure out all the relations that I can find, right? So let's try to understand what is going to be the set of relations. So I see, right, in the set of relations, if you figure out if A is less than equal to B, right? So that means every element is going to be related to itself, right? So I can say 1 comma 1, 2 comma 2, 3 comma 3, and 4 comma 4, right? Just a very basic thing to understand. Second thing is I can say 1 is related to 2, 3, 4, 2 is related to 2, 3, and 4, right? And 3 is related to 4, right? 4 is not related to any other element itself, other than itself, right? So last second thing is going to be 1 comma 2, 1 comma 3, 1 comma 4, right? And then 2 comma 3, 2 comma 4, and then 4 is not related to any other element. So 2 comma 3, 2 comma 4, 3 comma 4, and I think that's going to be all the relations that I can form. Now let's try to understand how we can represent this using a diagram, right? Now if you look at it, writing this down, right, writing all the relations is kind of a tedious task to do. So maybe using a diagram I can make this less tedious kind of a thing, right? So let's try to figure out what's going to be the diagram in this case. Okay, so I'm just going to represent this in a particular order, and I'll explain later why I'm doing it. But what I'm going to do is I'll consider 1 at the bottom, 2 up above it, 3, and 4, right? So now let's try to figure out figure out how to figure out the diagram, right? So first thing is I'm going to draw the loops around it, around every single element. So 1, around 2, around 3, and around 4, right? Because all the elements are related to themselves, right? Second thing is I'm going to draw arrows from one element to other if they are related, right? So I see 1 is related to 2, so I draw an arrow. 2 is related to 3, I draw an arrow. 3 is related to 4. Similarly, 1 is related to 3, 1 is related to 4, and 2 is related to 4 as well, right? So um, this is going to be the final relation. You can figure out, compare this relation set with this diagram. First, they are represented with the nodes, right? Second, I've drawn the loops because representing that they are related to themselves. And third thing is, wherever you see the arrow, that basically means that that element is related to the other element, right? So arrow going from 1 to 2 means 1 is related to 2. That's just a one thing to understand. If the arrow was from, if arrow was the other side, right? If it was going from 2 to 1, then the relation would be 2 related to 1, right? Just a small thing that I want you guys to keep in mind. So I hope you were able to understand how this exactly works, right? Each element is represented as a node. Just a quick summary. Second thing, draw a loop if they are related to themselves, and draw an arrow if an element A is related to an element B, right? Now, now the now also one thing we can do is we can also draw the partial order relations using digraph representations, right? What is a partial order? Once again, I'll just give a quick summary about it. A partial order relation is basically something which is reflexive, antisymmetric, and transitive, right? So this is still a relation, and we can represent this using a digraph representation. But when it comes to partial order relations, right, what we have is we have a better representation for them, right? The point is, if you look at this diagram, right, there's a lot of repetitive task happening over here. Look, first thing is, I have to draw all these loops again and again, right? So think about if I had a lot of elements and a lot of arrows going around, right? Then I would have to draw a lot of these loops around first. Second thing is, if you look at it, I have to draw these transitive arrows as well, right? So I have to explicitly show that one is related to 3, one is related to 4, and there's no shorter way to do it, right? So in case of partial orders, we have a better way to draw these diagrams, which is a more clean and neat way, I should say, right? And that is where we basically have the Hasse diagrams, right? Basically, what they do is they turn the Hasse diagram to a more neat version and more clean version, right? And the only thing is that we need to keep in mind and understand uh, what it basically represents, right? So now let's try to understand what is a Hasse diagram. Okay, now let's try to understand what is a Hasse diagram, right? I've not rubbed out this portion, right? Because this is what we are going to need for this part, right? So first of all, Hasse diagram is just a simple diagram used to only represent posets, right? So the first very important thing to understand is that we only use it to represent posets, which is basically the partial order relations, right? So what are the rules? Don't show the loops, don't show the arrows, and transitive edges are omitted, right? So basically, in very simple words, what we are trying to do is we have this digraph representation of a partial order, and what we can do about it is we can kind of make it more clean version of it, right? It's still, and it would still hold all the information that we can get out of it. So for example, this is the digraph representation of it. Let's try to convert this into a Hasse diagram, and you'll see how this makes it a very clean version of it, right? So the first thing is don't show the loops, right? So the first thing I'm going to do is going to remove all the loops in this case, right? So I remove this loop, right? The second one, I can remove the third one, right? And the fourth one, right? So I've removed all the loops. That's the first step. Second thing is don't show the arrows. So I'm just going to show this on this side, right? So I hope that works for you guys. So this is 4, 3, 2, 1. Okay. So don't show the loops. I'm not showing the loops in this case. Don't show the arrows. I'm not showing any arrows in this case, right? And transitive edges are omitted, right? So let's try to figure out what does it mean by transitive edges being omitted, right? So if you look at it, 1 is related to 2, 2 is related to 3. That implies that 1 is related to 3 as well. So instead, what we can do is, I don't have to showcase this specific arrow, right, which is going from 1 to 3. I'm going to remove it. Similarly, I see 1 is related to 2, 2 to 3, 3 to 4, and 1 to 4 as well. So instead of explicitly showing an arrow going from 1 to 4, I'm just going to remove it, right? So whenever you see a relation which we can kind of form through a path through the other elements, then we can just remove that arrow, right, explicitly. So I can remove this arrow, I can remove this arrow going from 1 to 3, because I can form a path from 1 to 2, 2 to 3. Similarly, I can remove this arrow from 2 to 4 because I can form a path from 2 to 3 and 3 to 4, right? So I hope that kind of makes sense. Just a quick summary once again, this is not that difficult to understand. Uh, just once again, the more you solve questions around it, the more you will understand how you kind of can remove this transitive behavior, right? Okay. So, so first thing, don't show the loops. Second thing is don't show the arrows. Transitive edges are omitted. And if you figure out, finally, this is what we will be left with. And this is going to be the Hasse diagram for this relation over here, right? So if you look at it, this is a very clean version of this relation, right? Like it literally is just a line. But now, one very important thing to understand in this case is, right, we are not representing the arrows. So how do we know exactly what the relation is, right? What is which element is related to which element, right? Is 2 related to 1 or is 1 related to 2? So the idea is very simple in this case. Since this is a partial order, right? Since this is anti-symmetric, which is relation is going only in one direction. Either A is related to B or B is related to A. It cannot be both. Point is, starting from the bottom to the very top, the arrows are going. So if you look at it, the arrows are actually going in this direction, right? So whenever you draw a Hasse diagram and if you see any elements, you should always remember that the relation is going from bottom up to the top. So that means 1 is related to 2, 2 is related to 3, 3 is related to 4, and not the other way around. So I'm going to give you another example in this case, right? Let's say I had this kind of a figure, right? Let's say this is A, this is B, C, and D. If you look at this, and I'm trying to interpret this Hasse diagram, right? First thing I need to understand is that A is related to B is related to D, and B is also related to C as well, right? That's how this is flowing. It's going kind of upwards direction, right? And second thing is this C is not related to B, D is not related to B, and B is not related to A, right? That's not happening in this case. So if I give you the question, right, let's just try to understand how we can convert this back into a diagraph representation. So it's going to be pretty simple to understand. First thing is I draw all the loops, 1, 2, 3, and 4. Second thing is I need to draw all the arrows. So I draw this arrow. Third thing is I also need to represent all the transitive relations, right? So I see A is related to B, B is related to D. That means that there was an arrow from A to D as well, right? So I'm going to draw that arrow. And similarly, A to B, B to C means there has to be an arrow from A to C as well, right? Remember, and also one thing, um, this C is not going to be related to D, right? Why? Because I cannot go in this downward direction and then go up again. Only thing I can do is I can go in the upwards direction in the Hasse diagram. So this is kind of a complicated thing to understand, but I think once you solve a few questions, it should become very clear about how this works, right? So once again, just a quick summary about everything, right? Um, Basically, in order to represent relations, right, we use the diagraph representation, right? So we draw the loops to represent the reflexive relations. We draw arrows whenever we see some element is related to the other element, right? And basically, we have this kind of a representation. But since this is kind of a messy representation, in order to have some better representation, which is more clear and still holds all the information that we need, we draw the Hasse diagram. But the important thing is that it only works for the partial order relations, right? So in the case of partial orders, we can use this Hasse diagram representations where how do we do it? For a diagraph, we first remove all the loops, we remove all the transitive portions, and we also draw a diagram in a way so that the relation is going in the upward direction, right? So this is the most important part, that the relation is going in the upward direction. And that is why in the first place, I drew these elements from 1, 2, 3, 4, and not the other way around, right? So I hope you were able to understand how a Hasse diagram works and what is a diagraph representation. If you have any doubts, you can leave in the comment section, but this is going to be very important to understand the future concepts that we are going to understand, right? Such as what is maximal elements, minimal elements, upper bounds, lower bounds, etc. Right? So Now, I'll be giving a bunch of questions for you guys to solve, and I'll see you guys in the next lecture. Okay, so I've given some questions on the board. I think they should be pretty easy to solve. Um, the very difficult part about drawing a Hasse diagram is usually the order in which we place the elements, right? So, um, drawing a diagraph can be very easy thing to do. You just have to draw loops around every single element, draw arrows wherever you see the relation. That's it, right? But when it comes to a Hasse diagram, right, you have to make sure that your flow is going from the down to the upward side, and you don't miss out removing any transitive relations or any loops, right? So it is kind of tricky to understand, but make sure that you keep all these properties in mind. And once you've drawn your Hasse diagram, whatever way it is, you kind of recheck your definition, right? You make sure that it is flowing from the bottom to the top. The relation is going flowing from the bottom to the top. You have removed all the loops and you have removed all the transitive relations as well, right? So for the first question, you're supposed to do the diagraph representation for this, right? My suggestion to you would be kind of try it in a way so that the bottom elements are at the very bottom and then it flows in the upward direction, right? So that your relation are going from one related to two related to three, etc. Right? So in an upward direction. That's just a basic hint for you guys. And convert the diagram from question one to a Hasse diagram. So if you already draw the diagram in that kind of a representation I'm talking about, I think converting it into a Hasse diagram should be an easy task. And the third thing is you've just been given this Hasse diagram, convert it into a diagram representation. So that's it for this lecture. In next lecture, we will be covering a few definitions, a few important concepts, right? So I'll see you guys in the next lecture.